looking even when I glisten. Ready to go, man? All right. So where we are right now is we're looking at separable differential equations. And as I mentioned yesterday, like separable differential equations are fun. We're going to spend 3 days here. You're going to get really good at this regardless of how well or how badly yesterday's homework assignment went. What makes a separable differential equation separable is the fact that you are able to separate the variables in such a way that you have a function of y times dy equals a function of x times dx, meaning all the y's are on one side times dy, not ever divided by dy, not dy under a square root sign, equals a function of x dx. If you're able to do this, then separation of variables is the way to go. And what would be your first move? If you recognize you have a separable differential equation, what's your first move?
Integrate.
You're going to integrate. Which side?
Both sides.
Integrate both sides. Okay, after we do that, Jose, what do you do?
You get the y on one side.
Okay, I'm going to say solve for y. And then your last step? Or maybe not the last step.
Plug it in.
I'm not necessarily worried about simplifying it. If I've solved for y, I've got like y equals blah.
The domain.
We're going to talk about the domain, but there's something that you need to talk about first.
Solve for C.
Yeah, solve for C. Right, so you could say solve for C. This is like use the initial condition. And then the final thing is check your domain. Because your goal, right, not the goal like strip your shirt off and run around the classroom goal, your answer needs to satisfy 3 conditions. The things I'm looking for here, the 3 conditions, number 1, has to be a function. Number 2, has to be continuous. And number 3, tell me about the domain. Now, a couple of things I want to point out here. Yesterday, we always went in this order where we integrated both sides, then we solved for y, then we solved for c. There are times where you're going to want to switch these 2 steps, and it's okay. Jeanette, before you ask the question, like, how do you know? How do you know when solving for c first is the way to go?
You'll know.
You'll know eventually. After you've taught the course for like 10 or 12 years, I mean, you'll start to figure it out. Wow, no laughs there. But kids watching the video at home are laughing. All right, you can solve for C or solve for Y either way, in any order. In fact, today I want to try switching it up a little bit. There are also going to be times where domain restrictions come from the initial differential equation, and I want to take a look at that today as well. We've only got about 25 minutes, which is perfect, because that's exactly what I planned here. I have picked 2 really challenging questions. I would rather us spend the time in class on the hard stuff than send you home with the hard stuff. Some of you are like, you already do that anyway. So take a minute. This is already like day 2 with separable differential equations. Read through this problem with your partner. Have a tearful moment if you need to. What's your plan? What you gonna do? Pick up the homework and people over 10 minutes. Homework pile over here. Anybody turning it in? Well, so everybody else, we are going double.
Yes, sir.
Okay, homework over here.
Double or nothing.
Everyone's going
It's
double.
not gonna be nothing.
Homework over here.
What are you?
Everyone's doing double. Okay, homework over here. Double.
Oh, really?
There's like a
Okay, friends over here. Anybody turn in the homework? Double. Double. Fine with me.
I think you have to show us a picture.
Some people don't know, like people recognize what I'm wearing.
Yeah.
Like my head's
Yep. Told you I chose a hard one. No one even has written down a differential equation yet. Yesterday was easy peasy.
Oh yeah.
Yesterday I gave them to you. Now I'm being mean. Determine the equation of the curve that passes through the point 1, 1. I saw a lot of people that said, oh, here's the initial condition. But out of 27 people in Calc AB, nobody has a differential equation yet. Where is it? Did I forget?
No.
Or did I hide this from you? I clearly hid it from you. Henry, where did I hide it?
It is in whose slope at any point x comma y is equal to 3y over x.
The slope at any point is equal to 3y over x. In a calculus class, when we talk about the slope of a curve, how do we talk about slope of a curve? That's dy dx. The derivative, right? One of the very first things we learned about the derivative forever ago was that derivative meant slope. So dy dx is equal to 3y over x. How many of y'all think you get it from here? Okay. Coming up with the differential equation in this case was meant to be a little bit of a pain in the butt. I know. Go for it. Go for it. Go as far as you can. And be your goal, all the y's and the dy's on one side, all the x's and the dx's on the other. Trust your algebra skills here. You never want to be dividing by the dx or the dy. A lot of folks have already multiplied by dx. So dy equals 3y divided by x times dx. Not a bad choice. Not a bad choice. That's legal. Have we separated the variables? No. You got the dy over here, you got the dx over here, but this side still has this mix together of the x's and the y's. I need legal algebra to have a dy side and to have a dx side. Divide by 3y. So the next move I'm going to say dy equals 3y, dy over 3y equals 1 over x dx. Is it legal to divide both sides by 3y? Yes. As long as you do it to both sides. Okay? You could make it dx over x, but honestly, I'm more worried about the way I chose to write this side. Because when we integrate, you just want to have that dx as the dead last thing, right? So a better way to write this is maybe 1 over 3y dy. Have we separated the variables?
Yeah.
We're going to see that? So at this point, Kevin, you just picked up the first point. You separated the variables. This also says, hey, this is a separable differential equation. Now you're just going to run through your process. Integrate both sides. Solve for y. Use the initial condition. Check for the domain. Keep going. Keep going. I want to see what you guys can do. For some reason, I've got to shake it up second minute. And nobody wants to see me do that. Here, I'm going to buy a spare shirt.
I don't know.
You're the only one that asked.
This is a little too late for that.
Maybe not.
I guess
No. I'll save my money, pay my daughter to pay for college. Seeing a lot of success on one side of the equation, but maybe not the other. Rubio's got it.
Did you really have to think about your options?
Of course I think about my options. Integral of 1 over x dx. Natural log, absolute value of x plus c. How many of you guys honestly had natural log absolute value of x plus c? And you had the absolute value bars.
Yes.
Good news, so that's supposed to keep track of points. You just picked up a point here, and because you remember the constant of integration, you got another point. Now I've got to integrate 1 over 3y. It is not natural log of the absolute value of 3y. It's not. The integral of 1 over x is natural log of the absolute value of x. Let me give you a little nudge here. This is the same as saying 1 over 3 times 1 over y dy. Gonzalo, what are you going to do?
We'll take out the 1/3.
You're going to take out that 1/3, which is legal because this is a constant. And so now you've got 1/3 times the integral of 1 over y dy equals the natural log of the absolute value of x plus c. And everybody knows what the integral is here. This is natural log of the absolute value of y. We don't bother writing. We absolutely do not bother writing the plus c because we know we would subtract it later on and everybody's going to be okay. And you probably pick up another point here. We're not done. We know we're not done. Not done because?
You gotta get the y by I.
You got to get the y by itself and you got to use the initial condition. You got to do both things. Now, yesterday we always solved for y first, then we use the initial condition. I want to use the initial condition first. So this is like early use of initial condition. If I use the initial condition, which said, what was it, y of 1 equals 1? This means that if x equals 1, y is equal to 1. So let's do that. 1/3 natural log of the absolute value of 1 equals the natural log of the absolute value of 1 plus c. Natural log of 1. Everybody needs to know this one.
0.
Natural log of 1 is what again?
0.
0. 0. What's c?
0.
C is 0. Now that you've used the initial condition and figured out c, you pick up another point. Oh my God, we're almost there. 1/3 natural log of the absolute value of y equals the natural log of the absolute value of x. You're so almost there. So close. You're going to multiply both sides by 3, so we get natural log of the absolute value of y is 3 times natural log absolute value of x. You still haven't solved for y.
E.
Right? We're gonna exponentiate. What was that word?
Exponentiate.
Exponentiate. E-X-P-O-N-E-N-T-I-A-T-E. I'm not multiplying by the e. I'm raising. I'm using the previous equation as my exponents. Now what happens over here? The e and the ln inverses absolute value of y is equal to e to the 3 times natural log of the absolute value of x. Because of that 3 there, the e and the ln will not cancel out. Paul,
What if you put the 3 inside of the
what do you want to do with the 3?
3, like raise the x to the
Is that legal?
Yes.
It is absolutely 100% legal to do that. And so now you get absolute value of y equals e to the natural log of the absolute value of x, the whole thing cubed. Now you've got the e and the ln exactly where you want them. So you can say that the absolute value of y equals the absolute value of x, the whole thing cubed. We're so almost there. So almost there. There's one thing left. Not the domain. You haven't solved this for y yet. You think you have, and you haven't. Because you've got to get rid of the absolute value bars.
Do you just erase it?
Now you might just be like, well, they're there, I'll just stop writing them. That's not solving for y. Marilyn?
Isn't it the domain?
No, it's not the domain yet. The absolute value of y equals the absolute value of x, the whole thing cubed. Absolute value bars are only there to make negative things positive. And what happens with positive things? They stay positive. So if the absolute value of y equals the absolute value of x cubed, then y is either the positive version of the absolute value of x cubed, or it's the negative version of the absolute value of x cubed. We have to choose. Is it the positive version? Is it the negative version?
Positive.
How many guys are going for the positive version here? How many guys are going for the negative version? How many have no idea how to choose? Be honest. Thank you for the honesty. Okay, for those of you that don't know how to choose, somebody help them out. How do you make this decision between the positive and the negative version? Jackie, what are you going to do?
Look at the initial condition.
You look at the initial condition, and what about the initial condition is going to tell you how to choose?
If the y is positive, it's to be positive domain restriction.
If the y value is positive, I need to go with the positive version here. So that's why we're going to choose the positive. So let's go through. We set up the differential equation. We solved the differential equation by integrating both sides. We used the initial condition early. You didn't have to do that. We solved for y. I think we're done. Except for one thing. There's one thing left, and it's a big thing. Domain. Are there any domain restrictions here? Is there anything that you can't do? We can't take square roots of negatives. And the other thing?
It's a cut.
Hold on, that's not a cuss point. There's two things we can't do in math.
1 over 0.
You can't divide by 0, and you can't take the square root of a negative number. Are either of those things happening here?
No.
No. However, you also have to check one more place, and yesterday we weren't ready for this. The other place that you check, the initial differential equation. When you look at the initial differential equation, are there any domain restrictions here?
Yes.
What's the domain restriction?
0.
We can't let x equal 0. Some calculus teachers say, hey, like check in the beginning and check in the end. Some people say, hey, just finish the problem, and if you have time, go back and check. I think getting in the habit of checking in the beginning is going to be better for us. So if x can't be 0, right, we did this yesterday, here's 0, I can't choose 0, I have to choose. Do I get numbers less than 0?
No.
Or numbers greater than 0?
Greater than 0.
That seemed pretty strong and pretty consistent that it's going to be x greater than 0. Rebecca, do you know why x greater than 0? Plugging in a negative number isn't the problem. How did we decide to use the positive version? You went with the initial condition, right? Because the initial condition says that the x is greater than 0, you have to choose where x is greater than 0, given a choice. Okay? We're doing good work here. You guys are doing just fine. Your brains will survive this, I promise. Okay, try the next one, see what you can do.
If it ain't be all the negatives, then we skip 0.
But then you can't be continuous.
Oh.
Right? When you think about drawing a function that's continuous, no brains. You can't go from all the x is less than 0 and then jump over where x is greater than 0 with a continuous function. Okay? Great question. Hey, Jose. You have a note for me? Do I have homework for today? Yes, about, I'm going to email you about, you need the packet because you've not been here for 3 days in a row.
It's the 1.
Is it well, you just divide by
They don't like initiate. Yeah, people.
Everybody's on the second one.
square root of x times.
Yes, Sheila.
So I just divided 3 times the square root of x. I mean,
No, well, we eventually solved for y. I used the initial condition early, and then we solved for y. We could have solved it for y.
the x times the root of
You're going to do both steps, but that order is intentional. You have to integrate. You would still have to. Determine the equation of the curve which satisfies the differential equation y dy dx. 3 square root of x e to the negative y squared.
Yeah, to break this. Use O
What?
then.
I got y times dy.
It's just, I did something.
Move the y before the.
Okay, we've got about 6 folks that have already successfully separated the variables. Good choice. Multiply by dx. Y dy equals 3 square roots of x, e to the negative y squared dx. I know this is ugly. I know it's ugly. And then you're going to divide both sides by e to the negative y squared. So y divided by e to the negative y squared dy equals 3 square roots of x dx. How many of you guys honestly made it here? All the folks that made it here, you've already earned the first point. You did no calculus. You just did algebra. Gonzalo.
So for like the e to the negative y squared, I was confused on whether to use log in order to cancel it out or just divide by it.
Well, here's the we're not trying to cancel out right now. We're just trying to separate the variables.
Oh,
Okay. Your next move? We're gonna integrate both sides.
Yeah.
And there's always an easier side and there's always an uglier side. I think we know the easy side here. The right side is the easy side. And if you're like, no, it's not the easy side, yes it is, because square root of x is really x to the half. If you can successfully integrate this, and remember the constant of integration, you're about to pick up 2 points. To integrate 3 times x to the half, add 1 to the power, and then divide by the new power. 3 divided by 3 halves is 3 times 2/3, that's 2, plus Charlie. You got a point. You got a point. Now this part over here, yikes. Chosen especially for the smarticle particles that are in the room right now. The integral of y divided by e to the negative y squared dy. That's kind of scary. Kind of scary. Kind of ugly. Kind of got a lot going on. Got a lot going on here. There's a clue. There's a clue. Jeanette, what are your thoughts here?
Can you take out the y from the top because there's a y squared at the bottom, so it'd be 1 over negative y?
No, the negative y squared is an exponent. It's not this times negative y squared, it's an exponent. Let me say it one more time and see if that gets across the plate again. That's really scary looking. It's got a lot going on. A whole lot going on. Axel. I'm going to pretend you said try integration by substitution. You did! Not. What I'm hearing is a lot of folks want to cancel out the E right now. Like you want to like bring on the ln.
Yes.
That's not our goal right now. Your goal is to integrate. And one last time, this is really scary, right? There's all this stuff going on. But that's the clue.
Oh.
That's the clue.
The uglier it is.
The uglier it is, the more likely substitution. So what's the baby?
E minus y. I mean, e to the negative y squared.
I'm going to go with this guy here. So u is negative y squared.
But that was like everything at the bottom.
Sometimes it's the stuff in the bottom. Sometimes it's the exponent. If you do that, you've got du dy equals negative 2y. And most of the folks in the room are like solve for the dy first kind of situation. You like that? So you multiply by dy. Du is negative 2y dy. Divide, you're going to get that du divided by negative 2y equals dy. In the rewrite, you're going to have the integral y e to the u power dy is du divided by negative 2y. And that might make you want to throw up a little bit. But good stuff's about to happen. The y's cancel out. That negative 2 that's in the denominator, you know how to handle that.
1/2.
It's going to be a negative 1/2. which is a constant I can take out. Negative 1/2 the integral of 1 over u, that's a du. 1 over e to the u, not kind. Not kind at all. Don't know that I know how to integrate 1 over e to the u. It's kinder than this.
E to the negative.
Isn't this the same as e to the negative u? What has e to the negative u as its derivative?
Negative e to negative.
Negative e to the negative.
This would be negative e to the negative u. So you've got negative 1/2 times negative e to the negative u, which is the same as 1/2 e to the negative u. I know we got a lot going on here, but u is negative y squared. So it's 1/2 e to the negative y squared. We get 1/2 e to the y squared. I have never, ever, 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 ever in my life seen the College Board ask a separation of variables question that hard, that ugly, that involves integration by substitution. I just created it because I have high expectations. It's true. So now we're at the point 1/2 e to the y squared equals 2x to the 3/2 plus Charlie. We've only got 2 minutes left. The good news is you've done all the hard stuff. I swear to you, all the hard stuff is done. What's left?
The 3.
We got to solve for y. We've got to solve for c. Is there an initial condition somewhere?
Yes.
Where?
4. 4 is
There's an x-intercept of 4. An initial condition needs to have an x and a y. The x-intercept is 4. Is that the x value or the y value? The x value is 4. The y value is 0. If you plug everything in, we know x is 4, we know y is 0. 1/2 e to the 0 equals 2 times 4 to the 3/2 plus c. We're almost there. E to the 0 is 1. You've got a half. 4 to the 3/2. Square root of 4 is 2. 2 cubed is, what is that, 8? Times 2 is 16. C is, I'm just going to call that 31 over 2. Just to finish this off, 1/2 e squared equals 2x to the 3/2 plus 31 over 2. The only thing you have to do now is solve for y. Still got to solve for y. Quick moves here. Multiply everything by 2. Then you're going to get rid of the e. How does that go? Natural log.
Square root.
Then you're going to take the square root. And you've got to consider the positive or the negative version there.
Positive?
It's the negative, the y values have to be negative. I'll see you guys later. I'll send you my worked out solutions for this one so you can have complete notes. Hey Zeus, turn it off. Of me? Sure.